Good evening, everyone. So I'm going to record, well, I'm not sure if it's evening for when you're watching this, but I'm recording this in the evening. Um, just want to make sure I get the videos for chapter 9 this week. I'll probably be doing the videos for chapter 10 on Friday, December 2nd. So that I'll have those up in plenty of time for you guys to look at next week. And that's the last topic they're going to be covering. And it's only two sections, and that is not terrible, but some of the skills required to do this in StatCrunch are going to be a little sophisticated because we're a little understanding of what it is you're solving for. And that's going to be a topic you're going to be learning new. It'll be like only maybe one question, two questions tops on the final. So not too much to worry about, but do make sure that you watch those. All right. So in the notes, and this is all included in the notes in the video page of the notes, and this is the last page of them, I am providing four problems. Two of these are going to involve hypothesis testing with summary data. And then the other one's going to be hypothesis testing with raw data, which works pretty similar to how we did it for section 8.3 in the last chapter. But in this case, we're gonna have to type it in to do it. So, but that's okay. Numbers aren't too vast here. So let's go ahead. This is the new section 9.2. It's question 12. And this question, they have kind of all the information here gathered together quite nicely. So that's not too bad. So what we'll do is we will um, 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 do the known alternate here. I'll get the level of significance, and then we'll just type everything in, and then we'll come up with a conclusion. So we're going to kind of keep it short. I'm not going to write the final conclusion like step 5. I will say what it is, but I'm not going to actually write it down. I try to keep this video should focus on the calculation because I've done enough of those examples and the way those sentences are framed are all going to be the same for this section as well. All right, so it says here, um, use a 5% significance level to test the claim that the mean IQ score of people with low lead levels is higher than the mean IQ score of people with high lead levels. So, um, people that have, so what we're going to do in this case is we're going to say mu of 1. That's going to be low lead. And mu of 2 will be high lead. And what these values represent here, these represent IQ levels. And what we're saying is that people that have lower lead content in the blood have higher IQs. Yeah. So in terms of the known alternate hypothesis on this question, we're going to say that the people with lower lead levels have higher IQs than those that have higher lead levels. So mu of 1 would be greater than mu of 2. So I think the first time we've seen a comparison of doing hypothesis testing with two means. So this first one here, we have mu of 1 is greater than mu of 2. What's the null hypothesis going to be? Very similar to what we did in 9.1 with two proportions. Mu of 1 is equal to mu of 2. And that's going to be the same null hypothesis when you're doing two means, regardless. Level of significance in this question would be 0.05. And then here, what we're going to do is we're going to go ahead and take all the information that's organized here. And we're going to put this in StatCrunch and then see how this is done here. So let's make this video StatCrunch first. And then we'll share how we do this in StatCrunch now. All right, so this time I'm going to go to Stat. I'm going to go to T-stats again because we're working with a T-distribution since we only know these sample standard deviation, not population. Two samples with summary data. So T-stats, two samples with summary data. Okay, and we're going to take the information that's right on the sheet here. I'm going to bring the sheet right over here. Given the sample mean, and I get this really to like a really crazy number. 92.8462. Doesn't really need to be that accurate, I don't think. Sample distribution is 16.3451. Sample size, that's going to be 78. For sample 2, we have 86.90476. Sample standard deviation is 8.98352. And then the sample size is going to be 21. Okay. So we never click this because we're not going to study information that's appeared that would be covered in section 9.3. We're not going to use that, so we're not going to worry about that. In this case here, we're going to say this is going to equal 0. It's like always going to be 0. And here we're going to say because the alternate hypothesis includes greater than, we're going to use a greater than symbol here. The critical value here is 0.5, so we're going to include that there. So click share show critical value, and then let's go ahead and click compute, and let's see what we have for this here. All right, so you'll see here that we have the critical value of 1.67, a t-statistic of 2.28. That's definitely higher than this. And then we notice that our p-value is 0.01. Yeah. So we're going to go ahead and write that down for step 3, that we obtained a p-value of 0.0132. Bring that back over here. And of course, the question we always ask is p less than alpha. Is 0.0132 less than 0.05? Absolutely. Yes, it is. Therefore, reject the null hypothesis. Now, it should be worth mentioning here, I didn't mention this before, that this is the claim. So when we have the claim focusing on the alternate hypothesis, and then we reject the null hypothesis, you go to that sentence frames on page 6. What you want to say about this, that in terms of the last statement, is going to be, there is sufficient evidence to support the claim that, where is it? That the mean IQ score of people with low blood lead levels is higher than the mean IQ score of people with high blood levels. So, and that has been researched for a long time, so that's established that. So definitely having high levels of lead in the brain or in the blood does not help with the mental acumen. Okay, so we have the answer to that question. Again, I got to write all the statements here. I'm just focusing on how to do the calculations of this and how to do the initial steps here. Number 13. Oh, one thing here. I didn't do a confidence interval for this one. So let me go ahead and construct the confidence interval for this one. And now for the confidence interval, it doesn't specify what the confidence level. So we're going to assume that the confidence level is going to be based upon the level of significance, which is going to be 1 minus 0.05, which means my confidence level is going to be 95%. Yeah. So we're going to go back to the problem now and find that confidence interval. And let's do that here. You have the confidence level 95%. And if as long as you go back and hit edit, you don't have to worry about putting anything else in, and just hit compute. And if you take a look at the confidence interval, I'll show how this is going to be around. So we see the lower one must be 0.7 to we'll say 0.7, yeah, 0.729 is less than, this could be mu sub 1 minus mu sub 2, and that's going to be less than 11.231. I'm going to go ahead and show this here. Okay, so here is, let me adjust this like this. Okay, so here's our confidence interval. What you'll notice is that this is positive and this is positive, which means 0 is not on the interval. 0 is going to be back somewhere this way, because this is positive, and because 0 is not on the interval, this would also allow us to reject the null, because 0 is not on the interval. Reject the null hypothesis. And when you do this, you should in fact reach the same conclusion as we have when we did the p-value. So That's typically what's going to happen here. So I hope that makes sense, but we'll go and do another problem. But the next one we're going to have to just do a little tidying up ourselves. Okay. So it says, are male professors and female professors rated differently? Well, they should be, since the male professors are likely to be more superior. And don't hold me to that, of course. I know that's very sexist joking and all that whatnot, but just trying to lighten things up a little bit. You guys, I think, pretty much know me. All right, so use of 5% significance level to test the claim that two samples of course evaluation scores are from populations with the same mean. So we're saying that mu sub 1 is equal to mu sub 2. Basically that the means are not different, they're the same. All right, so you have the information there, so I'm going to put this together. So this is going to be question 13. Mu sub 1. And get the information about, I'm going to get the information about the male professors first. Let's see. Oh no, they have the information of female professors first. Okay, so forward thinking. Who will be the male professors? The null hypothesis, the alternate hypothesis. So the claim is that mu sub 1 is going to equal mu sub 2. By default, that means that the alternate is going to be mu sub 1 is not equal mu sub 2. This is the claim. That's the first part. The second part, the level of significance is going to be equal to 0.05. Now, number 3, here's where we got to be careful because we're going to need x bar 1, s sub 1, and then we're going to need n sub 1. Now, they don't indicate that way on the sheet, but I'm going to indicate that. So, and there, this is going to be for the females. The female professors, n is equal to 40. X bar is equal to 379, 3.79. And then the standard deviation is equal to 0.51. If x bar 2, s, no, s sub 2, s sub 2, this is going to be for the male professors, and it's going to equal 53. X going to be 4.01. Ooh, gee, look at that. Oh, no, sorry. Me is going to be 4.01. That seems a little higher than the females. And that's going to be 0.53. Okay. So we have the data there. And again, the level of significance will be 0.05. What are we looking for? We're looking for the p-value. And we're going to see what that's equal to. So now we're going to go ahead and take this to StatCrunch again. We're going to go stat, stats, to sample with summary. And let's put everything in. Be careful. Make sure you're putting in the sample mean with this. So the sample mean for the first one would be 3.79. Sample standard deviation would be 0.51. And the sample size is going to be 40. Sample mean for the second one is going to be 4.01. Sample standard deviation is 0.53. Sample size is going to be 53. Yeah, and the null and alternate correspond because this is going to be clean, and the alternate is not that the sum is not equal to 0. Since we have not equal, we're going to keep that not equal symbol there. We're going to show the critical value and a level of significance of 0.05, and we hit compute. And you notice here that we have that p-value of 0.046. Now this is really, really close to 0.05. And you recall if you watched one of the previous videos, when we had a p-value that was very close to the level of significance, when we did the confidence interval testing, we had to consider the idea of changing the confidence level a little bit. Well, in this case, no, actually, we're not going to have to do that for this one because this is going to be this is a two-tailed test because the alternate hypothesis is not equal. So that's not going to be a factor here. So the value of p is going to equal to 0.046. So we're bringing the information. In fact, let's we'll come back to that in a minute. Let's bring the information back to our paper here. In question 4, I'm going to ask, is p less than alpha? Oops, hold on. So is 0.046 less than 0.05? Yes, it is. Therefore, reject the null hypothesis. Now, the null hypothesis is the claim. So that means we're rejecting the claim. So the conclusion on this is, since the claim focuses on equality, and remember, your sentence frames on page 6 from your notes from chapter 8. The claim focuses on equality. We reject the null. We're going to start off the conclusion to say there's sufficient evidence to warrant rejection of a claim that the pool of teachers are male and female professors are rated equally in this. They are not. We're not saying which one's higher. Of course, it appears that the males are rated higher, but that could come up for a number of reasons. But all we're going to say is that they are. We reject the claim that they are equal. Or we reject it. There's sufficient evidence to warrant rejection of the claim that male and female professors are rated equally. All right, well, let's go back and look at the confidence interval. All right, and in the question here, it doesn't specify, let's see, yeah, it says to construct a 95% confidence interval for this one. So we're going to construct a CI. We know the confidence level is going to equal 0.95, and it's going to be mu sub 1 minus mu sub 2. And we want to get the numbers to that. So let's go back to StatCrunch. Hit edit. I almost zero this out here. To see myself out of work. There we go. So I'm going to keep all the information in there, hit compute, and you're going to notice, take a look at that. Now that is getting really close to zero right there, but it is still negative. So this is negative, this is negative. It does not contain zero on the interval, which means we should reject the null hypothesis. So the for the sample mean is going to be 0.436, negative 0.436 to negative 0.004. So the confidence interval we have on the paper here, which would be from StatCrunch, would provide for us the same conclusion because zero is not on this interval. We would, again, based on that, we would reject the null hypothesis. Okay. So hopefully by seeing some examples of these and trying to use your own, this will begin to make sense. Okay. Last 2 questions here are going to require a bit less work. So I just go ahead and keep the work to this page down. Because here we're not going to have to worry about writing what the sample mean are and everything. We're actually just going to type this data in and then answer the questions. Okay. So, it just did like, they actually asked so they asked the same question, but actually from the data. I didn't realize that they did that. Well, let's see how this game is played with this one. Is this the data they're looking at? Probably not, because we take a look here in the original problem we looked at. We had a sample data of 40 and then 53. We were looking at a much smaller sample size, so we're not likely to get the same results. But I wonder if the conclusions that are going to be reached are going to be the same. Probably not, because the sample sizes are slightly different, much smaller in this case. So how do we do this here? Let's see. Test the claim that female professors and male professors have the same mean. Okay, so this is going to be the same as what we had in 13. So again, we have females and males. So mu of 1 is going to be female. Mu of 2 is going to be male. For our null hypothesis, then, mu of 1 is going to equal mu of 2. That's the claim. Our alternate hypothesis, mu of 1 is not equal mu of 2. Okay. Level of significance, that's again going to be, you know what, they don't give one in this question, or at least it doesn't appear so. So this is a good example to show, because when they fail to give a level of significance, you may simply assume that the level of significance is going to be 0.05. Okay. So, and I'm just going to put here, we assume. Remember that when it's not provided, you may assume that it's 0.05. So what we're going to do now, you're going to go to StatCrunch, we're just going to type that information in. we're going to get our p-value. So that's what we do in step 3, and then we're going to run a comparison in step 4. Notice that this one does not ask us to do a confidence interval with it, so we're not going to do that. Now, if you're doing this in StatCrunch, you will not have to worry about typing this information in for yourself. Okay, but I'm going to go ahead and type this information in right now. I'm going to title this here so I don't choose this later. All right, and just be sure that you're typing all. You won't have to worry about sending this in because it will transfer on its own. Oops. Okay. Put that ifs on. Put that there. Put the mail part in. 4, 2, 3, 6, 4, 5, 4, 5, 3, 5, 4, 5, 6, 0, 4, 5, 3, 4, 5, 5. These just seem to matter a little there. That, of course, is just observational. And notice when I put 4.0, just kind of changes it automatically. So now what I do when I run this calculation here, I'm going to go to stat, t-stats, 2 samples with data this time. Okay. So t-stats, 2 samples with data. So the only difference is we go with data. And then values in the column 1 female. The answer column 2 will be male. So that way it does the kind of comparison we're looking for here. Since we have a null, the claims on the null hypothesis, the alternate hypothesis is not equal to 0. This won't matter, but in the case where we're looking at 1 is less than 1 is greater, it will matter. We will assume that the significance is 0.05. This is correct because we have MESA 1 not equal to MESA 2, so we're fine here. We click compute. And yeah, when we take a look at this here, and we take a look at the p-value of this. Now, I think shouldn't have anything wrong. Yeah, probably just what it is that there may be some difference, but the value is so small data. You get a p-value of 0.75, so it's 6. So not much of a difference there at all, really. Yeah, when I look at these, yeah, I see some of those are pretty high. So let's go back to the paper and bring that conclusion over there. Oh. Okay, so for number 3, I get p is equal to 0.7576. And then for step 4, I'm going to compare p to alpha. So is p less than alpha? Or that is to say is 0.7576 less than 0.05? Oh no. Therefore, we fail. We fail to reject the null hypothesis. Now, in the case where the claim is focusing on equality and we fail to reject the null hypothesis, again, look at your sentence starters on page 6 of the notes in chapter 8. We say there is not sufficient evidence to warrant rejection of the claim that female professors and male professors have the same mean evaluations rate. So that is a bit of a different conclusion from what we reached in the previous example, because we did reject the null hypothesis. But in this set of data here, we have a smaller number of data to look at. So that would likely explain why we're reaching a different conclusion at this point, at least with this set of data. Okay. So no confidence interval to consider here. So we will consider 17 done. And then we will look at 18. This is the final question we're going to consider. Again, it's going to involve typing data in. Okay. Let's see. When the author visited Dublin, Ireland, home of Guinness Brewery, employee William Gossett was first developed the t-distribution. I think I mentioned this in class, but I'm not sure if I did or not. He recorded the ages of randomly selected passenger cars and randomly selected taxis. The ages can be found from the license plate. There's no end to the fun of traveling with this author. Oh God. Yes, he has a really terrible sense of humor. The ages and years are listed below. We might expect the taxis would be newer. So test the claim. Okay, so test the claim that the mean age of the cars is greater than the mean age of the taxis. So we're gonna see that the car ages will call the muse of one cars. Muse of two is taxis. So the claim seems to focus on the alternate, where we're talking that the age of the cars is going to be greater than the age of the taxis on average. That means that the null hypothesis is going to be mu sub one is equal to mu sub two. Okay. So we have that in place now. That's number one. Oh, and this is the claim. What's the level of significance? It doesn't provide one, so we're going to assume that the level of significance will be 0.05. And if you do assume that, just indicate that that's an assumption. For number three, we're going to go ahead and type this information. We're going to find the p-value of this, and we'll start comparing this. Okay, so again, I'm going to go ahead and type this information in once I share this. And we're typing up here our taxi. Trying to do this as expeditious as like 10, 4, 0, 8, 11, 14, 3, 4, 4, 3, 5, 8, 3, 2, 7. 4, 6, 6, 1, 8. 3, 5, 11. 4, 1, 6, 1, 3. Hopefully I didn't make any significant mistake that's going to throw off the results of this, but we'll work with data as I have it typed in anyway. Just for the sake of the lesson. So this will be P 0 3 8 4 3 3 6 11 7 7. 6 9 5 10. 8 4 3 4. Okay, now the numbers aren't equal, so that's okay. All right. So again, here, let's go to step T stats, 2 samples with data. Okay, I just said it before. If you pause the computer to take this down, that's perfectly fine. Okay. The first one, because that's how you have the defined from use of one, that's going to be car. Second one's going to be taxi. That's why what labeling helps kind of keep things organized. For this one, we're going to assume we're assuming use of one is greater than use of two, so we're going to put greater than here. And we're going to assume level significance is 0.05, so we're going to hit compute. And we look here, and the p-value is 0.6175, not exactly a winning p-value. So let's go and write that down and go back to our worksheet. The p-value on this one, 0.6175. And then for question 4, we're going to ask the same question. Is p less than alpha? So at 0.6175, is it less than 0.05? No. Therefore, we fail to reject the null hypothesis. And because remember, going back to that those sentence starters on page 6, the claim is not is focused on inequalities and things not being equal, and we fail to reject, then we would use a sentence starter. There is not sufficient evidence to support the claim that the age of cars is the average age of cars is greater than the average age of taxis. And that's what we would say about this. So I hope you found this lesson to be helpful. And please reach out to me for any questions and feel free to refer back to this as much as you need for help on this. Thanks.